I think I drew your attention when I was going over the different monatomic ions. I pointed out the mercury issue. Both mercury 1 and mercury 2 have a what charge?
Wasn't like neutral or something?
Yes, very good. How did you know that? Oh, and it's also on the back of your periodic table. But right, both mercury 1 and mercury 2 have a 2+ charge on their ions. Does anyone remember how we differentiated between the two ions then?
It's like 1 divided by 2 and 2 divided by 3.
We have a little bit of recollection going on. So, mercury 1 is the diatomic ion, meaning has 2 atoms. Okay? Chloride, as we all know, is 1-. Okay, so to write the correct formula, you would have to write Hg2Cl2. Is everyone okay with that?
Sure.
Okay.
No, I don't know.
You're not okay with it?
Yeah, I don't know what you did.
Well, I have 2 positive charges, and I have 1 negative charge. So I find the least common multiple of 2 and 1, which is 2. Okay? Well, I've already got 2 positive charges here, so I'm okay, but I need 2 negative charges here. Okay? That's not the issue, though. That I was anticipating. But currently, nobody's thinking it all the way through. Yes?
Wouldn't it be Hg1?
Thank you. No, it wouldn't. But that's exactly what I was expecting you to say, because if you guys remember, up here, had we not written Cr2O6, isn't that what you guys started off with Friday? Okay. Some of you left it there. Some of you went ahead and reduced it, right, to this. And I said we want to have the lowest ratio possible. But I'm telling you, this is correct. I knew that would happen.
Why?
Because if I left it, if I reduced it to this, don't write this down, what does this imply? Well, what's the charge on chloride? 1 negative. If this is 1 negative, then this has to be 1 positive. And there is no such thing as mercury with a 1 positive charge. So this you are not going to reduce to show that it's mercury 1. So what I did there, if you guys follow along, I just did a standard old ionic compound, use the charges off the periodic table, blah, 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 blah. I did the same thing here. Here I introduced a transition metal that can have more than 1 charge, so I showed you which particular iron it was. Okay, no problem. Here, very similar thing. I used 1 of the chromiums. In this one, I used another of the chromiums and then talked about how we would reduce to write the lowest ratio possible. And then here I showed how we're not going to do that with mercury.
Oh, for that one, how would it be different if mercury was 2?
That's a good question. So what are we going to do? Well, no, here's what you do. You say, you would figure it out on your own. So what's the compound that you would like to have? Does everyone understand her question? She asked, what would it be if it were mercury 2? Well, here's my thought to you. Find out.
That is a good idea.
So, what are we going to do?
Find out.
How are we going to find out?
Writing it down.
Writing what down? Mercury 2 what?
I give up.
Go ahead, Kaylee. Yeah, Mercury 2 what, though? We have to have something to write a formula for. So pick something. Sure, why not? Mercury 2 chloride. No, come on, people. Find out. Okay, so Mercury 2 chloride. What would we write? Well, we would write, what's the symbol and charge for Mercury 2? With a 2 plus charge. Chloride, we already know, is that. So wouldn't it look exactly like this? No? That's not right? Okay, what's the lowest common multiple of 2 and 1? 2. So I have to have 2 positive charges. Oh, look, I already have that. I need to have 2 negative charges.
Didn't you say that there's no such thing as a mercury?
I did not. I said there's no such thing as a mercury atom with a 1 plus charge.
You did say that.
Is that what that would be, though?
It's a funny looking boy.
Never mind. Never mind.
Are you better now?
Yeah, never mind.
Okay.
I was overthinking.
I know. I know. At least you were thinking,
Yeah.
which is better than
No thinking.
many. Okay, is that better, Emily?
Mm-hmm.
Okay, so you asked what the difference is, now you know. Which is actually going to be a good point because later, as you guys can probably guess, currently I'm giving you the names and asking you to write the formulas. Later, you're going to get the formulas and have to write the names, so this ends up being an issue, as you can imagine. I mean, it's already an issue going from the name to the formula. You can imagine the issue we're going to run into going the other way. So you helped everyone be introduced to that idea. All right. Those were our examples. Let me see. I walked through, 2 or 3 examples, I think. Then I had you guys try these on your own, right?
Yeah.
We're on to the next thing. So, what's the next thing?
Writing atomic ion.
Now, as I just heard someone say, writing ionic formulas with polyatomic ions. Now, these are the ones that you guys have been studying for the last 3 weeks that you only knew about for 2 weeks, right? No, actually, you've been studying for 3 weeks, you only knew about for 1 week.
Yeah.
Okay. So poly means more than one, okay? So the polyatomic ions are going to be those ones that are on the back of your periodic table that I showed you guys. So you may want to have that available since I'm going to guess that not everyone is incredibly comfortable with it yet. It's exactly the same as binary compounds. Exactly the same idea as binary ionic compounds. It's just that one or more of the ions is going to be a polyatomic ion. You guys following?
Mm-hmm.
Okay, so here's the rules. Same as usual. Write the symbol and charge for the cation. Now, the cations are going to be the metals. Remember, the positively charged ion. Metals are positively charged. However, there's one exception, the ammonium ion. That is the only, that you guys need to know, positively charged polyatomic ion. It's the only one, okay? Because remember, I've told you guys you have to ask yourselves whether it's ionically or covalently bonded to figure out which set of rules to use, okay? And I said, hey, the way to figure out if it's ionic is to look for a metal. I'm telling you right now, if the ammonium ion is in it, there's not going to be a metal because nitrogen and hydrogen clearly aren't metals. Okay? So that's the one thing you have to keep your eyes open. If you see ammonium, it's still ionic. All right? Okay, next. Then write the symbol and charge for the polyatomic anion. It's almost always going to be a polyatomic ion. And then the rules from there are just exactly the same. Charges cancel, write the formula. If the charges do not cancel, use either the lowest common multiple or a crossover method, blah, 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 blah. Okay, so I'm going to go ahead, even though the three examples that I provided for you are clearly written there, I'm still going to walk through the process. Okay? So here we go. First one, silver cyanide. Okay? Well, is this an ionic compound? Okay, well, everybody's going to say, well, yeah, duh, that's what we're studying. But how would you know? What's the piece of evidence? What's that? Nope.
Silver?
Silver. Silver's a metal. Ionic compound. So we write the the symbol and charge for silver, which everyone knows is Ag with a 1 plus, because silver is one of the three that you're going to have to memorize. Cyanide. Okay? Does anyone recognize cyanide yet? Probably not, because you haven't studied these. Well, again, this is why you're going to have to do that. Cyanide is Cn with a 1 negative charge. Do the charges cancel?
Yes.
Yes, they do. So we just write AgCN. All right, next, copper 2 chlorate. All right, is this ionic? Why? Copper is a metal. Symbol in charge for copper 2 is Cu with a 2 plus. Chlorate. Notice that's not chloride. Okay, so that means it's a polyatomic ion. You guys would happen to know because you memorized these that chlorate is ClO3 with a 1 negative charge. Do the charges cancel? No. What's the lowest common multiple? 2. So I need 2 positive charges. Ding, 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 ding. I'm good. I need 2 negative charges. Dung, 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 dung. I'm not good. So what am I going to have to do? I need 2 ClO3s. So all I'm going to do then is write Cu, ClO3, 2. Isn't that what I did with the other ones?
Nope.
Sure it is. Except does that look a little strange?
Yeah.
It almost looks like it's 1 copper, 1 chlorine, and 32 oxygens. That's a lot. Okay, that doesn't exist. So how am I going to show that there's 2 ClO3s? Well, it shows there, I believe, doesn't it? Yeah, you're going to use parentheses around that component. You don't have to write this next piece down. I'm just showing you what it means. That means that I have 1 copper 2 ion that has 2 positive charges. It needs 2 negatively charged particles to balance that out. Here's 1. There's another. So I could, and again, I'm asking you not to write this down because I don't want it to confuse you. Could I not write this? Could I write it like that? How many chlorines are here? Okay. How many chlorines are here? 2. How many oxygens are here? 6. Or could I write it like this? Here's my question to you. Which do you think would be more efficient so that you know what it is? Writing this, or this? This, because you're going to know. You've got, some of you have already made flashcards, right, for the polyatomics. Did you write ClO2O6? No, you wrote ClO3, and you're going to remember it as ClO3. We just need to show that there's two of them, so we put it in parentheses and put a 2 out here. Okay. You'll get better at this. What's the last one? Oh, well, let's see if we can apply what we learned earlier. So, mercury 1, as we all know, is a diatomic ion with a 2 positive charge. Nitrate, as you're learning, is NO3 with a 1 negative. Do the charges cancel? They do not. Lowest common multiple is 2. I need 2 positive charges. Ding, 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 ding. I need 2 negative charges. Don't have it, do I? So, what am I going to write? Hg2 NO3, and the way we say that to each other so we know what we're talking about, we'll say NO3 taken twice. So that way you guys don't have to sit there and go, Hg subscript 2 parentheses nitrogen O3 parentheses subscript 2, which takes 4 years. Or you can just say Hg2 NO3 taken twice. Okay, let's give you guys some to practice. And clearly, for now, you guys are going to probably need to refer to that polyatomic ion chart. You're also going to recognize as we're doing this why it's useful to have these in your brain so you don't have to keep looking the dang things up all the time. Because right now, you're going to tell me the answer to 4 times 6. Boom. How did you know that? Because you've known it. You're at some point in your life asked to memorize that.
Yeah.
Right. You didn't have to go get your calculator out. You didn't have to sit there and figure it out. You just knew it.
Yeah.
A lot faster that way, isn't it?
Yeah.
Right. Same thing with these polyatomic ions. Your life is going to be a lot easier just knowing what they are without having to look them up all the time. I'm trying to help you. You're welcome. All right, moving on. Here we go. I don't know. Let's go with, we're going to go 6 to 8 of these. When I get tired of writing them out. No. Oh, what else do I want? Lily, pick an element. Who? Oh, okay. All right, what else do I want? What else do I want? Oh. Oh, let's go with, and strontium. Okay, that ought to be a nice little set for you guys to play with. Okay, I'll give you 30 seconds. If you don't get them all done, you don't get them all done. I mean, that's just the way it is. It's no big deal. Okay. Keep on playing if you want to play, but... symbol and charge for calcium, everyone. Ca with a 2 plus. Carbonate.
CO3.
With a 2 negative. Do the charges cancel? Right. So what do? Ca, CO3. Right?
Yep.
You guys know this substance very, very well. I don't know it as well as I used to know it. When I started using a whiteboard, I quit knowing this. Yeah, chalk, calcium carbonate, chalk. Anyone ever have a Tums before? Anyone ever had a Tums? What did it taste like? Chalky. You want to know why? Boom, calcium carbonate. Thought you'd like that. Lithium sulfate. Someone charge for lithium. Li. Sulfate. Do the charges cancel? They do not. So I need lowest common multiple of 2 and 1 is 2. So I need 2 positive charges and 2 negative charges. I'm hunky-dory there. So Li2 SO4. Anyone 2 for 2? Okay, about half of you. Good. Aluminum nitrate. Al with a 3 plus. Nitrate is NO3 with a 1 minus. Charges cancel? No. Lowest common multiple of 3 and 1. 3. So I need 3 positive charges. I'm good. I then need 3 negative charges. So I write NO3 taken 3 times. Everybody wave to Mr. Homan, since you guys all wave to Dr. Bolden. Okay. Apparently you guys like Dr. Bolden better than you like Mr. Homan. Cobalt 3 phosphate. Symbol and charge for cobalt 3. CO with a 3 plus phosphate. Negative. And the charges cancel. So CO, PO, 4. Full for full. Lost a few. 1, 2, 3, 4, 5, 6, 7, 8. Maybe not. Potassium acetate. Symbol and charge, potassium. Acetate. C2H3O2 with a 1 minus. Charges cancel. So, KC2H3O2. 5 for 5. 1, 2, 3, 4, 5, 6, 7, 8. Gallium oxalate. Ga with a 3 plus. Oxalate is C2O4 with a 2 minus. Do the charges cancel? No. Lowest common multiple, 6. So I need 2 galliums and 3 oxalate ions. So it's Ga2, C2O4 taken 3 times. 6 for 6. 1, 2, 3, 4, 5, 6. Lost a couple there, but that's okay. That was going to happen. That's where it starts getting more fun. lead 4 chlorite. So we have a Pb with a 4 plus. Chlorite is ClO2 with a 1 negative. Charges do not cancel. So we write Pb ClO2 taken 4 times. Where are we now? I don't even know. 7? 7 for 7. 1, 2, 3, 4, 5. That's okay. These things happen. And now we're going to be 7 for 8. I don't know. We'll see what happens. Ammonium. Symbol and charge. NH4 with a 1 plus charge. Ferrocyanide is FeCN taken 6 times with a 4 plus or 4 minus charge. What? Okay. Charges don't cancel. Lowest common multiple is 4. So we write NH4 taken 4 times, FeCN taken 6 times.
What do you got there?
Is that 8? 8 for 8. Oh, look at this go. 1, 2, 3, 4. We lost another one.
Well,
It's okay. Oh, and then strontium ferrocyanide. So, strontium is Sr with a 2 plus. Ferrocyanide is FeCN taken 6 times with a 3 negative. Charges don't cancel. Lowest common multiple is 6. So I need 6 positive charges, so strontium get multiplied by 3. The ferrocyanide already has 3 negative charges, but it currently only has 2, so... And there we go. You should see the look on Emily's face right now.
How?
How what?
How is that 2 times? Isn't it 3? The charge is 3.
Yeah, 3 times.
Okay, watch this. Watch this. Emily, watch this. Okay? Because this is one of the examples Friday. And I'm gonna tell you it's exactly the same thing. Okay? What's the answer? Boom. There you go.
Then why am I confused?
This is what I'm asking. This is my question. Because this has a 2 plus. This has a 3 minus.
Yeah.
You're looking for 6.
What's the lowest common multiple?
6.
So I need 2 of these.
Yeah.
I need 3 of these. What's the lowest common multiple?
6.
So I need 3 of those and 2 of these.
I don't know what I'm thinking.
It was pretty complicated, wasn't it?
No.
Well, okay, but I mean, seriously, that kind of... Okay, how many ended up being 9 for 9? 1, 2. Yeah, right. See, I knew that was going to happen. That's okay. All I tried to do here was show you how this, which you clearly understand, is exactly the same as this.
Where does that 6 go? To the CN or to all of it?
To the whole... You notice how I put this in brackets? There was a reason for that. So just like
Isn't it already 6 times though?
the cyanide is...
Oh, this 6 is just for the...
Yeah.
Okay. That's
Yeah. How are we doing? You guys need to practice a little bit, don't you? Yeah. All right, let's do that.